Data Science at Yonsei University. I'm actually delighted to be here to present the topic regarding the theoretical and practical foundation of the robust visual prompting. First, we are going to see how transfer learning in computer vision has worked. In computer vision, transfer learning has evolved towards reducing the number of parameters. At the beginning, full fine-tuning model utilized all parameters, while the subsequent methods like prompt tuning, such as LoRa and adapters, leveraged only a subset of the parameters. And the paradigm of the transfer learning in vision is shifting towards the visual prompting, where the research focus on adjusting the input data while keeping the model parameters fixed. Actually, in the field of the natural language processing, prompt engineering and in-context learning have been active areas of research, and similarly, related research is increasingly being conducted in the vision domain also. And the objective of visual prompt here is to learn the prompt V, which is parameterized by phi. That minimizes the loss function when prompt is added on input data. And here, I elaborate on visual prompting methods by comparing original visual prompt called VP and black box visual prompting called black VIP, which is introduced by our co-author Changwei Oh in 2023. And in VP, once the prompt V is trained, it becomes independent of the input data during inference. In contrast, black VIP creates prompts that depend on the input data during inference, so that black VIP is more adjustable to handle with the different input data. And furthermore, VP needs to access the parameters to update the prompt. However, as the name black VIP suggests, black VIP can learn the prompts without accessing the model's parameters. And we also take this a step further by introducing black VIP SE, a more lightweight model. Actually, black VIP uses the encoder using a neural network to summarize the input feature information in generating input-adjusted prompts, but SE version introduced a statistical feature-guided approach. It means that it replaced the encoder with dimensionality reduction methods like PCA, so it reduced the number of parameters. And so this substitution reduced the number of parameters required to train the prompts and resulting in a more lightweight model. And we conducted experiments to verify how well black VIP and black VIP SE perform in few-shot transfer learning. And for the few-shot image classification task, we used the CLIP as the pre-trained model and VIT as the encoder. And also the data sets included diverse scenarios across a total of 14 benchmarks. The results are as follows. We calculated the scores for 14 data sets and compared them across different methodologies. MVP, which accessed the model's parameters, showed high performance. And in comparison, black VIP, which uses far fewer parameters, also surpassed zero-shot performance in most benchmarks. And additionally, in runtime table here, the actual time taken for both forward and backward and forward-only processes is presented here. And notably, the black VIP SE demonstrated its efficacy by taking about half the time of black VIP, highlighting its lightweight nature. And our research explains why prompting methods are effective by bridging the gap between experimental success and the theoretical understanding. And actually, currently, there is a lack of theoretical foundation, and we aim to address this by developing insights that reduce the gap. we address how these methods ensure generalization of prediction in classification with two key insights. The first one is that stochastic gradient descent stands for SGD, approximates sampling from a normal distribution. And then adding Gaussian noise creates a smoothed classifier, reducing the impact of unwanted noise and improving generalization ability. Okay, and I will introduce each one. And the first one is that regarding the stochastic gradient descent method. And when we update the parameter, in this case the prompt, in early phase, the optimization in parameter space can be seen as just approaching the local optima. But after the model reaches the local optima, in later phase, it involves circling around the optima and fine-tuning the parameters. And actually, this behavior is equivalent to sampling from a normal distribution, and which is suggested by the paper stochastic gradient descent as an approximate Bayesian inference. And so, in short, for sufficiently large time step t, we can consider that the learned prompt is effectively sampled from a normal distribution. And second one is about a randomized smoothing, which construct a smoother classifier G. And let's look at an example of classifying two-dimensional data points into blue and green categories to explain the smoother classifier G. You see a curved line here, and this line is, let's assume this line is a decision boundary. And dots located to the left of the curve are classified as blue, while dots to the right are classified as green. And consider this green adjacent to this line. And if we add noise like this one, sampled from a Gaussian distribution to this dot, then it is quite really likely to become blue here. And in this case, when we add some Gaussian noise from this dot, then the probability of being classified into blue becomes 5/6. Therefore, the smoother classifier here classifies this green dot as blue. In short, when Gaussian noise is added, this dot is more likely to become blue. The smoother classifier also categorizes it as blue. So the constructed G, we can say that it preserves the most plausible class when any noise smaller than a certain size R is introduced into the input. And furthermore, since the Gaussian noise added during the construction of G ultimately becomes equivalent to the learned prompt V here, so we can consider that prompt V creates a smoothed classifier. And in short, solving the optimization problem in visual prompting and black VIP is ultimately equivalent to constructing G, the smoothed classifier, and we expect this will help prevent unwanted noise. And in conclusion, our research introduced first the latter version of the black VIP called the black VIP SE for visual prompting. And then we analyzed the theoretical foundation on VP and black VIP based on our perturbation analysis. And actually, I hope this our perturbation analysis will increase discussion about some technique for handling